Hey, this is Jesse with Create This. Today we're going to strip down our Yeti 400. We're going to remove the top screws, pull out the battery, and we're going to try to repair the inverter on the Yeti 400. It died in one of the mistakes videos a little while back. We had a problem with one of the, I don't know what you call it, one of the accessories that we plugged into the front for my Robomo, and it seemed to fry the inverter. So I'm hoping that that's a fuse problem on the inside. So we're going to strip it down and take a look at the fuse and see if we can replace it. I think it's soldered onto the board. But first, before we do that, I've got a DC load hooked up to the Anderson port on the side, and I've also got my solar panels hooked up. So let's go ahead and remove the solar panels from the front. And then we'll remove the DC load from the side. But before we do that, we've got to attach the 12-volt fridge to the wall here. So let's go ahead and do that. This way it doesn't, run out of power and, you know, couldn't really see that, could you? Oh well. Yeah, got it plugged into the wall. All right, and then we can remove the DC load from the side. So now the fridge is purely on AC power, and we've got no input going into the Yeti 400. Isaac, if you will do the honors, let's take this bad boy apart.
Yay. And the left. Oh, wait. You want me to do the sides too?
I think the whole top comes off when you do that last one there.
Okay. This thing will be still attached to it.
Well, see if it comes loose.
Wait, what?
Be gentle. There might be wires attached.
Yeah.
Hey, there you go. There's your battery on the inside. All right, so we can just set that lid aside. And now what you want to do is use that same wrench to remove the left and right battery posts here.
You think?
Yep.
Okay.
You can see that this is this is not your traditional AGM battery because it's got screw-type terminals on the top. Usually AGM batteries have post-type terminals.
Will this shock me?
It shouldn't. It's just 12 volt. Usually 12 volt isn't enough to like penetrate your skin, so usually.
That scares me.
Yeah, well, I mean, if you got a needle and you like, you know, hooked it up to the leads and stuck it into your body, you'd probably get electrocuted. And also if you were standing in water or something, you might get electrocuted, but you're usually okay working with 12 volt. It's usually safe. Okay, and then you've got that crossbar across the top. Let's remove those black screws on the crossbar. That holds the battery in place so that it doesn't shift around.
Glad that they made it all one thing.
Just lift up your. You really don't want. Hey, Isaac.
Okay.
You really don't want your tool touching the positive terminal of the battery. Okay, that's
That thing?
yeah. That's a good way to like arc weld your tool to the battery. I don't think you had anything grounded when you did that, so you were safe. But you really don't want to let tools touch the battery terminals.
Okay.
You can use the bottom end of the tool, dude. There you go. Now you can just spin it around easily. Okay, there's your crossbar. All right, and now you can just grab onto that little plastic handle there, and you should be able to gingerly just lift the battery out of the case.
Let me put this tool up.
Try not to move the case too much because it's in the shot. Like you can put one hand, like maybe use your left hand to lift, and yeah, something like that. You got it? All right. Okay, at this point I thought it would be interesting to weigh the lead-acid AGM 12-volt battery from the Yeti 400, which is a 400 amp hour battery. It's 12 volts, 33 amp hours, which, doing the math, so yeah, it's a 396 watt battery, Now it's lead acid, so you can only use the upper 25% of that if you want to get like the longest life out of it, right? So let's go ahead and put that lead acid battery on the postal scale, Isaac.
Okay.
Yeah, it's right there.
This thing is heavy.
Yep. Okay, and that reads, let's let the deck stabilize here. That reads 22 pounds and 7.2 ounces, okay? Take that bad boy off. That's a Ritar RA1233. And now I've got my lithium ion battery from my e-bike, okay? And this thing is lithium ion. It is 400 watt hour, just like the lead acid battery. But let's go ahead and put the whole pack on the scale and see how much it weighs. This thing is only 5 pounds and 5.6 ounces. So exactly the same amount of power in a much lighter package. Pretty interesting, huh? So here's the case for the Yeti 400 by itself. Oh yeah, here's the lid. Good idea. 7 pounds, 6.2 ounces. So the entire case only weighs 7 pounds and 6.2 ounces, but what was the battery by itself? Like
22.
Yeah, 22 pounds. So by far the lion's share of the weight is coming from that lead acid behemoth. So if you use lithium ion battery packs in this thing, you could get what, 7 plus 5? So you could get a 12-pound Yeti 400 if you use lithium ion. That would be so easy to carry around.
Yeah.
It's less than 15 pounds. That would be amazing. Okay, go ahead. So we forgot to measure all of the hardware that we took out too. So there we go. All of that stuff is 4.7 ounces. So, you know, more or less inconsequential. All right, so that's it for the weighing portion of this. I thought that would be interesting. Let's finish tearing this bad boy down. Okay, so here and here are 60 amp fuses. Now, when you call up Goal Zero and you say, hey, I've got a problem with my inverter, the first thing that they want you to do is they want you to check these two fuses. I've already checked them, and they're fine. So at this point, you can take the whole front control panel out. There we go. And you can see some of the guts of the Yeti 400 on the inside. And you can't really see it, but down in there, there's a red fuse that's been soldered to the control boards. Okay, so at this point, what we're going to do is we're going to remove the front control panel so that we can gain access to that. So this is the front control panel, and then we want to gain access to this board in the background there. Isaac, you don't want to touch anything in there right now because it might still be powered up. There might be like a big capacitor in there or something, so you probably don't want to touch anything just yet. So in order to do that, what we're going to do is we're going to remove this wire, we're going to remove this wire, we're going to remove this wire, this wire, this wire, and this one here. And that should hopefully gain us access to all of this. Okay, so just in case I electrocute myself, I'm going to do this instead of my son. That way, you know, I haven't killed my heir. I'd rather I died than him. So just a disclaimer, I guess. You might not want to do this at home. This could be dangerous. You know, if you do it at home, if you choose to do it at home, you do so at your own risk. I'm not recommending that anybody do this themselves. I have Isaac here, so if I electrocute myself, you know, and stop my heart or something, he can call 911 for me. So that's good. Okay, so I'm going to start removing things. So the first thing I'm going to remove is this wire here, little itty bitty wire. And that seems to go, looking at it, it seems to go back behind this transformer here, okay? Next thing I'm going to remove is this wire here. It's not as easy. There we go. That's 2. And this one seems to go down to, I don't know, somewhere down in there. And then I'm going to remove this one.
There we go.
Okay, and that goes up here and also over here. Okay, so now what I'm going to do is I'm going to remove these Anderson connectors here. I'm guessing these are for the, probably the 12 volt DC load on the front of the panel. So it should be pretty simple. Just reach in there, hopefully without electrocuting myself, and pull them apart. There we go, they came apart pretty easily. Oh, and one more, this guy right here.
And the back.
All right.
One more. Well, two more.
Yeah.
Those are onto the back of it.
This is the temperature sensor probe. So when I put that back in, I'll just lay that down flat inside the battery compartment. So that's the front control panel removed. Okay, now at this point, I've tried to remove these fuses myself in the past, and they're in there extremely well. They're extremely hard to remove.
He's struggling a lot right now.
I mean, I don't even see that, like, flinching. It's not even wiggling. Maybe if I had a screwdriver or something.
Yeah.
Let me get a screwdriver. Okay, so I'm going to use leverage as much as I can to remove these fuses. Not because I have to, but just because I don't want to move the camera. I'm lazy, and I want to prove to you that the fuses are in good shape. And I also want to show you a good way to remove these in case you have to. So I'm just going to use a screwdriver with a flat tip here, and anytime you shove something like this into an electronic device, you run the risk of frying the device and yourself. Disclaimer, blah, blah, blah. Don't do what I do. Anyway, and I'm just going to use that as a lever to pry these out. Okay, that came out easily enough, and you can see that the fuse is not blown. It's in good shape. Do the same thing with this guy over here. All that on camera, Isaac?
Yep.
And there we go. That one's not blown either. Okay, so the only one left is this guy down in here. I don't even know if you can see that on the camera. This is kind of frustrating, but you have to remove the back plate because it's got a lip. The front plate has a lip that goes under the back plate. So if you remove the back plate, remove the bottom first, then the back plate, then the front plate. So I'm going to remove this one, this one, this one, and this one. He's just another YouTuber. He makes some awesome part disassembly videos.
Break something.
Yeah, I was going to say, you know, if it's not obvious to you, your warranty's probably void if you try this. So, on the inside here, there's this tape, and it seems like it's connecting the bottom to the frame. If I pull here, it seems like it's prying the tape. Yeah. Okay, so what I've done is I'm showing you a top-down view of the inside here. This is the battery tray, and I think what's going on is this foam core tape is just, you know, it's attached to the plastic underneath here, and it's keeping me from removing the bottom. So I'm just going to cut through the tape here. Okay. Not exactly a master with a razor knife. Okay. Yeah, there we go.
Oh, you forgot one. Forgot one.
Did I?
Yeah, that one.
Right there? Okay. guess I did.
Wow.
There we go. Now the bottom plate can come off. All right, let's see if we can just slide this out without removing anything. Maybe I'm an idiot. Everybody's an idiot sometimes. This was just my day, I think.
Oh, hey.
There we go, yeah. So let me change this view again so you can see a little better. Okay, so I'm just gonna, these cables are not really attached to anything on the board anymore. This one is. Remove that. All right, and there we go. There's our front face assembly thing. Okay, so looking at this, there are 3 screws here that attach the aluminum heatsink to the side of the chassis, and there are three screws similarly on the other side, okay? When you look at the chassis from head on, okay, so when you look at this from head on, you can see that there is a screw here, and there's a screw here, and there is one down inside this hole. On mine, there's a cutout for another screw there, but I don't actually have a screw there. I don't know if that's a manufacturing defect or what. So what we're gonna do is we're gonna remove the 3 screws on the side, 1, 2, 3, and then on the other side, 1, 2, 3, and then we're gonna remove 1, 2, 3, 4 screws on the inside, and the entire circuit board assembly should come free of the frame. Okay, so let's see what we've got here. Looks like we've got our heat sink, and it's still attached with putty or you know, temperature thermal grease or whatever there. I could probably just pry that apart, but I don't really want to. I might have to though. No, it looks like it's actually screwed on there. I see, it's kind of hard to show. I see screws there and there. There's our fuse that I was interested in. And it does indeed appear to be blown. Let's see if you can see that. All right, so as you can see there, it's very shaky, but as you can see, the fuse is indeed blown. I see a little bit of metal here, and it should be going across the gap here, but it's not. There we go. So it's a little hard to see, but that fuse is a 40 amp fuse. You can see right there, there's a 40 written on it. And turning it over on the other side here, it's got this, you can see on the side here, it's got this grease stuff on it. I don't know what that is. It's like a glue or an adhesive of some kind. Flipping it over onto the back. Like, these are our 2 contacts. So if I want to desolder those, I should be able to remove that fuse and replace it. All right, so at this point what we're going to do is we're going to remove the old fuse. It's a 40 amp ATC style fuse as far as I can tell. And we got some new fuses. We just got these at AutoZone. And yeah, 40 amp ATC. We looked for a fuse holder so that we could just replace, you know, the whole unit with like something that had like some leads on it so that we could, you know, get in there more easily without having to solder anything if this happens again. But they didn't have anything that would handle that kind of amperage. They had like a 30 amp fuse holder, but they didn't have a 40. So I think what we're going to do today, just to prove that this works, is we're going to unsolder it and then put everything back together and see how it works. Let's see. I can get the one loosened up pretty easily. Let's see if I can get good contact on both of them. Partial melt. There we go. So I've got it melted, but the glue here is still attached. It's kind of annoying. Let's see. Oh, look at that. Wow.
Oh, did it like break out?
Wow. I'm guessing that happened because the fuse failed. I think if the fuse had not failed, then it would have come out as a solid unit. But since it failed and there was nothing attaching the two bits of metal, it came out as two separate units. And also I appeared to have melted the plastic housing on the fuse quite a bit. You can see that there. It's all curled away. So yeah, that fuse, even if it wasn't damaged, that fuse is junk now. And this is going to be tricky because I've got to get it up in there. Yeah, it's just going to be tricky. All right, so I'm going to attempt to tin the tips of this fuse. Now, one of the things that I notice here is that the tips of the fuse were cut significantly before they were installed, and I'm probably going to have to do the same thing to my new fuses. So actually I need like some nippers or something to nip off the ends of that. Okay, so these are WIS M2, I think they're like aircraft shears or something. Anyway, they're used for cutting sheet metal. So I'm going to use these to hopefully just nip off the ends. How far should I go? Let's see. Okay. So hopefully to just nip off the ends right here. Try to kind of choke up on it because, oh shit. Hey, that sort of worked. Cool. Okay, and now I will tin the ends of this. Meanwhile, Isaac is on his phone. He has completely lost interest in the entire project.
Oh yeah. It's that amazing.
Freaking kids these days, man.
Yeah, we're so much worse than you.
All right, so I am just trying to tin the blades here without melting the plastic. I just want, you know, some good solder coverage there so they don't have a cold solder joint. I've got kind of a solder bridge going on here at this point. It's crude, yeah, but I got it.
Did it?
Yep. Okay, so if I were to do this over again, I would probably, I don't know, get like a piece of copper bar or something and put it across these bottom contacts somehow. You gotta find some way to distribute the heat across these two tabs while you're pushing it in there. But for now, I'll just try to clean it up and get all of the excess solder out of the way. If that worked, we should have power. Yeah, look at that. USB, 12 volt. Oh, I think my AC might have fried already. Okay, so it's dark. I took everything apart and I put a new fuse in and I put it all back together, and I scraped off some of the calcium deposits on the back of some of the circuit boards. We'll see if that makes any difference at all. I'm hoping it does. I'd really like this to be a successful project. So, it's all back together. I've got my tester. Let's see. We've got power. Ah, and it blew the fucking fuse again. Fucking hell.